Because knowing what it's doing helps you understand better where you want to kind of fight some of the performance issues and where there might be things you want to take a look at. And then, rather than read through the list, these are essentially the things I'm going to be talking about. Instead of wasting time reading them, we'll just go forward. I want to start with this great quote from Danny Simmons, who was a program. I always get this wrong. He was a high-up guy on the Entity Framework team. He's actually moved over to another team now, but he was very involved with Entity Framework from the get-go. He even worked on object spaces, which was the first time Microsoft tried to do an ORM. And he and I were doing a webcast together, and he said this, and I went back to the webcast and listened to that and wrote it down and put it in my book because I thought it was such great advice about doing performance optimization for Entity Framework. He said, just approach it the way you would any other application coding, right? Start by just getting the code down there, doing what's the easiest to write, what makes the most sense, and what works, and then go back and tweak, right? So some of the things that I want to use profiling. That's why I've got the big words, right? Profilers. So not just query profiling, but also you can use .NET profilers, right, to just see where things are slowing down in the application. And they're not always going to be related to Entity Framework, but sometimes they are going to be. And again, you'll be learning about what those kinds of things might be. So I just think that's really, really great advice, rather than trying to, go for all the performance stuff right up front when you don't even know where you're going to be having problems. So about profiling, I just want to put this up front because it's really important. You'll never know, unless your performance is really, really bad, right? Like so horrible that it's really obvious to every user, or so horrible that the IT admin or the database administrator comes banging on your door, right, saying, what are you doing to my server? You really aren't going to know where you're paying performance that you don't need to be. So profiling is really important. Who here uses one sort of profiling tool or another? You're already doing it. Great. So here I happen to use the performance profiler in Visual Studio because it's in Visual Studio Ultimate, and that's what I use when I do perf profiling. But there's also others for really profiling your application. But it's also really important to see what's going on in your database, right? We're talking about Entity Framework. It's all about data access. So it's really, really important. We were stuck with only really being able to use the database-provided profiling tools like SQL Profiler. But now there are great profiling tools out. I'll be using one of them, the Entity Framework Profiler. And there's also others that you can use. There's a link at the end. I wrote an article about using query profiling, doing query profiling in Entity Framework, and it goes through all of them and shows you a little bit about them and has links to them. And I have a link to that article at the end of this deck. So, the application profiling and query profiling, it's just so important, and I really, my big message is we've got some really good Entity Framework specific profiling tools. So here's the first thing that I think is really important for people to understand, and I see this happening all the time when people decide to do their own benchmark testing. They say, let me go ahead and compare what queries are like with Entity Framework and data sets and SQL Profiler and nhibernate. Let's go and query it. And what they'll do is write one query and execute it as the whole application, right? They run the application, and it runs the query, it spits out the data, and the application ends. And then they write on their blog, oh my God, the Entity Framework performance is so horrible. It took 20 times as long as everything else. Is because they don't know what they're testing, all right? So it's really important to understand that this is what, if they did a second query and a third user runs the application and then shuts it down. But if it's a website, that'll just happen once and then happen again. when, if somebody turns, the server goes off and back on again. So it's once per application. So it's good to understand that. And this is all default behavior. As a matter of fact, it's possible to force that loading, the SQL for those entity sets. So if you have customers, it creates the SQL for those entity sets so that Entity Framework doesn't have to do that when it's executing the query. So it does that for all the entity sets. And that's something that you can get out of the way before you even run your application. There's a command line tool that's part of Entity Framework called EDMGen. And one of its parameters is view generation. That's not the right word. One of the things you can do is ask it to generate the views, to pre-generate the views for you. And the code looks a little bulky, but I just wanted you to see what that is. So you'll already have your model, and you just point to the different model files, and then you can pre-generate those views. And I'll show you what one of those looks like. I have it open in one of these. Here it is. Okay, now it would be better if I've got the font nice and big, but unfortunately it makes it hard to see here, but I want to make sure you can see it back there. So what it does is you point, not only do you point to your model, but you point to the project, and it'll generate a class and put the class into the project. And so it gets compiled right into the project, and therefore Entity Framework won't need to do all that work at the beginning. So what it's doing here is it's read through the model and found all of the entity sets and literally created in this case T-SQL, because I'm using SQL Server. It's created the T-SQL that Entity Framework will need anytime I query the activities entity set. So it doesn't have to do all that work. So that's one of the things you can do to avoid that big hit at the beginning of the application. But I think for me, more importantly, is if you're going to be doing comparisons, if you want to do some benchmarking and performance tests, take this preloading and the other application startup stuff into consideration, and do some warm-up queries so that you really know what you're looking at. That first query that happens on the model really isn't representative of Entity Framework's performance. Okay? So the next thing I want to talk about is change tracking. So if you're using Entity Framework, you're probably familiar with the fact that one of the big keys of its feature set is that it keeps track of objects in memory, keeps track of the changes to those objects, and then you can go ahead and call one simple method, save changes, and it will send everything back to the database. So change tracking is really, really important. The way that works is that it's the object context that you do. You use the object context to execute your queries and call save changes. So it's the object context that keeps track of what's going on in the entities that it's tracking. And what it does is for each entity that you're keeping track of, or that the context is keeping track of, the context creates another little class. It's actually called an object state entry. So if you do a query for every object, every entity that's returned, not only is Entity Framework going to give you an instance of each of those classes, it's also going to stop and create, for every one of them, create one of these object state entries. So that's a lot of work. Not only that, but anytime you make changes, and this is how the change tracking works, anytime you make changes, Entity Framework will update the state info. And when you call save changes, it doesn't look at your objects, it looks at the state information to build its update and insert and delete commands. So that's where all the important stuff is happening. And it's important. That's one of the reasons we like using Entity Framework. But it's not always something that you want. What if you're building lists in your application, a drop-down list, right? So with a drop-down list, I don't want it to do not only all this extra work it's going to do when I query for that list, but I don't want it to be maintaining. It's using processor time, it's using resources, maintaining all of those state entries, even if you're not making changes. And when you call save changes, it's going to go and read through every single one of those state entries to see if any of them need to go to the database. So if you're using a drop-down list, you're adding so much extra work to Entity Framework that it doesn't need to be doing. So I just want you to see what that looks like. Make that go away. And I'm going to start up the Entity Framework Profiler. Remember that was one of the query profilers I talked about? If you're familiar with NHibernate, it's written by the same people because they had an NH profiler and they've written a bunch of different profilers for different ORMs. And so they wrote one for Entity Framework also. So that's running, and it's going to keep track of anything that gets sent to it. And the way that I'm sending stuff to it is I have a reference in my project to the Entity Framework Profiler, DLL, and then all I have to do is call this command at the beginning of my application, and that's it. That's the only thing I have to do in my application to get Entity Framework Profiler to read everything. I don't have to go into config files. I don't have to add classes. All I have to do is add that one line of code. There's one extra line of code I have down here, and this is really just for demoware. The demoware that I'm doing, where I'm just doing a really quick thing, it's just so that the profiler will actually capture things at the end, because I don't want to sit there and wait for it to finish its process when my quick little querying is happening. So I'm just going to run this little bit of code where I'm querying for a whole bunch of customers out of my database. And then I'm also going to do a couple little modifications. And we'll take a look at those state entries. And then I'll go ahead and save changes. And so I'll just run that. Actually, the profiler will be for later. Okay, so the first thing I want to do is just look in the debugger at those state entries. And there's a lot of them, right? Those aren't my domain classes. Those aren't the customers, but those are those state entries that the object context is keeping track of. And I can get very caught up with drilling in and inspecting them. It's really fascinating. But I have so much else I want to show you today, so I won't bother doing that. So those are all the state entries. Now, when I go ahead and call save changes, I can't see my keyboard very well. Okay, we can see that it updated two things. So what it just did was it read through all, I don't know how many there were, 270, read through all of those state entries, found two that needed updating, and just sent those two commands to the database. That's what the number 2 represents, what went to the database and successfully was executed. All right? So if this was a list, what I could do instead, so it's the default behavior that we get the change tracking entities. What I want to do, now I have to say this is going to be different for the new stuff in Entity Framework 4.1 versus if you're coding against the Entity Framework 3.5 or 4. Okay? Entity Framework 4.1 introduces a streamed, kind of a stripped down object context. It's called DB context. So if this code is using DB context, and the code is a little different for turning the change tracking off. That's why I'm pointing it out. So what I'm going to do is right here where I have the context, and I'm saying query the customer's entity set. I can say as no tracking. That's it. As no tracking. So now when it queries those customers, it's not going to bother building all the change tracking information. So we'll run it again and just look at the same things I looked at before. So there's nothing. The object context is not keeping track of all of those, the state of all those entries anymore. And this is important to realize because you might accidentally do this, right? You've turned no tracking off and you make changes, Entity Framework's not going to know about them because you're not tracking, right? There's no tracking. So if I've made changes and I call save changes, and that number is going to be 0 now. Okay? So this is actually a really big improvement you can make because there's probably, in many applications, there's so many places where you want data, but maybe it's for reporting or, again, for pick lists in an application. You don't have to change track all that stuff. So are you thinking of your applications? Can you see how that would reduce things enormously? So that's something I end up working with clients when they have me come in and analyze their code. This is a big thing that we spend some time on. Just because of the short time, I'm hoping to do those at the end. Is that okay? I don't want to be rude, but you'll ask the question and I'll spend 20 minutes answering because it's going to be such a fascinating question. So I mentioned this is real data. I actually was. It's not important what I was doing, but I just wanted you to see kind of the difference in the time it took to do a query with a certain number of records when I was. I think there was it's that same one, so it was like 450 or something like that. But the difference in time that it takes to do all that extra work. And I also just wanted to point out, as no tracking is really nice. DB context and DB set make things a lot easier to code with. If you're using Entity Framework 3.5 or 4 and you're using object context and object query, the way you would turn no tracking off is with object query dot merge option equals, it's an enum, so it's merge options dot no tracking. But with that, you can't do that with a link query. You have to either set it on the entity set or cast the link query to an object query to do that. All right, so I'm just putting that in your head so you're aware of that. If you're doing a link query with object context and you want to take advantage of that. Okay, so the next thing I want to talk about is querying entities versus querying projections. Are you familiar? Does everybody know what I mean by the term projections? When you explicitly say select this, 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 and that instead of go get the entity. Instead of get the customers, get customer first name, last name, and all of the orders for that customer. So that would be a projection. And this is another thing that I just want to point out that if you are profiling and performance testing, you might notice this and go, oh no, projections are horrible, right? Because on the first query of a projection, if you do a projection, the first time you run that query, Entity Framework and also the database has to do a lot more work than the next times you execute it. So don't judge by that first query, whatever you're doing, whether it's the first application query. So I just wanted to make sure that big, huge bar didn't freak you out because look at the next one. The next one is about the same. Of course, it depends on what it is and what it is that you're querying and how you're doing that, how complex it might be. So then there's and this is kind of performance and also kind of just, coding strategies, good practices with coding strategies to consider with projections. So I have an example here, and it's a no tracking query, right? It's a list that I use frequently throughout my application of customer names and IDs, right? So I have a method here which will give me back this drop-down list. And I'm doing a projection over and over again. And because I need to pass it back, you know, a projection, when you do a projection, you get an anonymous type, right? And if you want to use that elsewhere, you can. An anonymous type only works within its method. So what I did here was I just created another class so that I could project into the class. So that's what I'm doing there. So an interesting thing to consider, again, performance and also just kind of a not best practices, practices to be aware of so that you have choices and you can make good choices depending on what's happening in your application. And the idea here is to consider using a database view and creating an entity. Do you know that you can map entities not just to tables, but you can map them to views? So you could create a read-only database view of that customer ID and name, and then just do a query of entities. You won't have to do a projection anymore. You won't have to create an extra class, and it will be pre-generated, right? Because Entity Framework does that pre-generating. So there's so many options and things to choose, and one strategy isn't always going to be the answer, right? Even for one application, you might say, you know, for this area of the application, it makes sense to do this projection. But for this other, it might make sense to have an entity with a view. Watching the time. I'm used to like 90-minute sessions, hour and 45 minutes. So here's another thing that can affect performance in your applications. It's about loading related data. Okay, so if you want customers and orders, that's what I mean by loading related data. And there's so many different ways you could do it. Here they are. You could do what's called eager loading. Okay, and eager loading is, and I want to review these first so you know what I'm talking about. I want to make sure everybody's aware of what we're talking about. So eager loading with Entity Framework, you do that using the include method. And then you explicitly say what path you want to include. So I want to query customers and bring back orders and details. All in one trip to the database. Okay? Projection, we just looked at projection. You can explicitly say what it is that you want to bring back. There's explicit loading. And explicit loading is when you didn't eager load, right? You just get the customers are in memory, but now you want to go get some orders. So you can say, the customer instance that you're working with, .orders, .load, and Entity Framework will automatically go to the database and bring those back for you, so you don't have to write another query, and then you can work with them. Okay? That's explicit loading. And then the last one is lazy loading. And lazy loading got introduced in Entity Framework 4. And the difference between explicit and lazy is that you never have to explicitly call load. It's just there. If I only queried customers, and the customers are what are in memory, but then all of a sudden I start talking about orders, Entity Framework will go, oh, just a second, let me go get them. It's not quite that way. Actually, what it does is it tracks whether it's been loaded or not already. If you loaded with eager loading or loaded explicitly, there's a flag that says it's already been loaded. That won't happen with projection. Oh, that's actually a good performance tip to think of too. So with the lazy loading, it'll say, hey, has it been loaded yet? Have those orders been loaded? No? Okay, let me go to get to the database. Now, if you did a projection and lazy loading is turned on, and then you did this, it won't recognize that they're already there. They might already be there, but projection doesn't give you that is loaded true. It doesn't change the flag. So it will do this again. So you'll have queried these things 2 times. And all of these things, you'll never notice. All you'll know is the application works. It works just the way you want it. And this is why the profiling is so important. You'll look in there, right, and go, wait a minute, why did I go get the orders for that exact same customer 2 times? Let me go back and look at my code and see what's going on. I would never notice something. And that's how I know that. I didn't know that because I read it somewhere. Since I wrote the book, I had to be the one to discover it and write it down. So that's actually a really important thing to think about for performance. So now that we understand what the different strategies are, I want to talk about the pros and cons of them. And some are performance related, some aren't necessarily, but I didn't want to eliminate or ignore the other pros and cons just because I was only talking about performance. So with eager loading, it's really handy. You've got one trip to the database. All your data comes back. And it's also easier to code. You don't have to worry about going back and getting data after the fact. But there is a big performance problem. And actually, it's not something I could demonstrate very quickly. This is one of those kinds of things where a client, would call and you would go in and would really look and do a lot of testing and stuff. But with include, you can actually do a lot of includes, so across different navigations. And the more includes and the more paths you add to that include, not only does your query get uglier and uglier, but the performance on the database goes down, down, down. The performance is really, really bad. Okay? So I'm not saying the include is bad, but if you're using include, again, keep an eye on the profiling to see what's going on, because that might be creating problems, and then you might want to start looking at one of the other strategies. So projection also gives you a single database trip. It also, not performance issue, but it gives you granular control about what you're bringing back. With eager loading, explicit loading, and lazy loading, you can't control what comes back. If you say, give me orders, it's going to give you all the orders for that customer. It's not going to you don't have the ability to filter or sort or do anything like that. So again, there's a big performance issue you might want to consider. And in that case, if you do want to be able to filter what's getting loaded, then you want to think about projection instead for performance. Okay, another thing to consider is with projections also comparing to using stored procedures or views. And again, pros and cons to each of them. But there's something interesting I want to show you about stored procedures. And I'm not talking about stored procedures that you map to entities to do insert, updates, and deletes. Are you familiar with that capability? That you can hook a insert stored procedure to an entity, and that will override. Entity Framework won't generate the insert command. It will use your stored procedure. So that's one thing you can do. But there's another feature in Entity Framework called function imports, where you can turn a stored procedure into a function and just call that function. So that's what I'm focused on right now. That's what I'm going to look at right now. And that is, it's up here. Just in this one spot is where I got the light. Okay, so I have a stored procedure in my database that I imported into my model. And it's called get line items for order, and it takes one parameter, which is the order ID. All right? So I call the order, I call the stored procedure, and the stored procedure returns an IEnumerable, which means I can go ahead and add link methods to it. All right? Entity Framework lets me do it. .NET lets me do it. Everybody's happy. And as a matter of fact, if I run this, and I've got a filter. So if that particular order has like 30 line items, and it just has a handful that have more than 10 as the order quantity. So what I got, no, that's not what I want to look at. I want to look at big line items. What I got back is 5 line items. So it's great, right? My application's working. It's doing exactly what I expected to do. I said, just give me some of those line items from the stored procedure, and it gave them back. But there's one problem. Stored procedures in a database are not composable. The SQL Server, Oracle, whatever, you can't, well, there might be databases that know how to do this, but the ones I'm familiar with, you can't compose on top of a stored procedure. all it is able to do is execute the stored procedure. So if I go over look at nhibernate, which has been keeping track of all of my queries, this is the last time I executed a query on a context. Oh, I haven't gotten to here, so I haven't flushed it. Run it all the way through. Okay. So all that went to the database is get line items for orders. And that got executed. And all 27 orders got returned to my application. So all of them came back from through the pipe, and all of those are now in memory. And then what happened at the end was it wasn't an entity framework query. An entity framework link to entities query would be executed on the database. I was just adding a link to objects query to that list of line items that got returned. So again, it's another one of those scenarios where it works. It looks like it's doing exactly the right thing. It was easy to code, right? And that could be a huge performance problem in your applications. Has anybody run into that before? Or are you going to go back and look at your application now and go, oh my God, I might have done that and I didn't realize it? If that's the case, then that's a win, because that means my coming all the way here was worth it. Okay, so that's something to be paying attention to. All right, now I want to talk a little more about query execution. And how many people here use entity SQL instead of link to entities? Okay. There's something this will pertain to entity SQL also, just in a different solution. And I'll point it out just for you. So when you run a query, whether it's a link to entities query or an entity SQL query, actually link to entities does one more process up above here even. Link to entities has to parse out the query and then send it to the object context. Okay? Then the object services takes that and turns it into something called a command tree. Actually, I don't know, you guys and girls might all be comp sci majors and know everything about command trees. I was a history major in college, so I didn't know what command trees were. Anyway, it breaks it down into a tree of commands, the commands and the values and everything that is represented in that query. And then passes it to another API and entity framework, which then takes it again and turns it into another command tree. The first command tree was based on the entity data model, so my classes in my model. The second one, it's actually gone out and looked at the metadata and translated it into a command tree that's all about what's in the database schema now. Okay, so and this is any time I execute a query. Okay, I've called toList. It's going to go through all of this, and then it goes to the database provider. The database provider takes the command tree, passes that native query, creates a native query based on the command tree. So T-SQL will be different than O-SQL, right? The DB provider will write the correct query and executes it. Then the results come back in a DB data reader, and then goes back up to object services, except if you're if you're just working in here. But it goes back up to object services, and we get the objects. So all of that happens when you execute a query. That's a lot of work. So can you imagine having a system query, maybe get customer number 3, get customer number 4, get customer number 5, or that's an easy query, but maybe a more complex query that you use frequently, and having to go through all of that. I mean, those pre-generated views don't solve your entire query. They just do the entity set part. But then entity framework has to add on all the other logic you've built into your query. So that's a lot of work. So entity SQL, for the one person who's using it, but you all may come across a scenario where it makes sense to have entity SQL to solve a particular problem in your application. Entity SQL will take this and the original query and put it in a hash table that lives inside the application process. So anytime it comes across that query again, even if the parameters, the values of the parameters have changed, it will skip all of this and go straight to the SQL. So it won't have to do all that work. So it does that with Entity SQL. It does that by default. You can turn that off if you don't want to. Link to entities doesn't work that way, but link to entities, and link to SQL does this also, takes advantage of something called compiled queries. Okay? And what you can do is you can take a query, but Entity SQL did this stuff for you in the background. You didn't have to worry about it. With link to entities, you have to do a little more work. With link to entities, what you can do is pre-compile the query, and then anytime you want to execute the query, you take that pre-compiled thing and invoke it. And you can use send different parameter values in over and over again. So all that work that was done here doesn't have to get repeated again. All right? So this is really scary-looking code if you've never done any functional programming before. As a matter of fact, I had never seen code like this before until I had to learn about precompiled queries. And this is in C#. It looks the syntax is a little different for Visual Basic. So what I want you to get, and I'll show you a little demo. I don't expect you to be memorizing this and understanding totally what it does. I just want you to get the concept and just remember, oh yeah, I should think about using a precompiled query. And let me show you the impact of it. So I have a web application here, and this is actually in VB. I haven't coded in VB in a long time now, but I used to be totally a VB programmer. And what this does, I'll run it first so you can just see it. It's just a simple little web application. It uses object data sources and ASP.NET web form. Pretty simple stuff. It grabs a customer and then displays all the orders for that customer, and then you can display all the line items for a particular order. Okay? So there's a lot of repetition going in there, right? I'm like querying for those line items, and all I'm doing is changing the key of the order over and over again. So there's somewhere where I can really take advantage of precompiled queries. Now, there's something interesting, just something you really need to be really aware of here. That's the same, by the way, that shared in VB is static. Visual Basic 6 already had the static keyword for something else, so when .NET came along, they couldn't use it again. They had to come up with a different word. So we got static in C# and shared in VB. This is especially important in web applications. I actually had, I came across a blog post where somebody said, I used precompiled link queries, and it didn't make any difference at all in my application. It's because she wasn't using shared. I'll show you why that's a problem. So what happens here is I'm using an object data source. That's one of the drag and drop controls. And each object data source on the web form is tied to a different class that provides the data for that one. So there's one for customer, one for order, one for details. So I have a customer provider class, a detail provider, order provider. They essentially look the same, except they work with different classes. So I'll just focus on I want to focus on the detail provider. So here's what's going on here. I'm defining a class level variable that is a func. That's the class that it is. It's a func. I always want to say function, but it's a func. And I'm saying that this func is tied to my sales entity model. I'm going to pass in an integer. Now, if I was passing in a lot of parameters, I would list them in that spot, in that middle place. I would list all the different types that I would be passing in. Here, I'm just going to be using the integer, that sales order ID. And then the final parameter is what I'm going to return from the func. So I expect it to return an iQueryable of details or line items, details. Okay, so that's actually not so complicated. So all I'm doing there is declaring it, defining what it looks like. Now, when I'm running the application, actually, why don't I just put my breakpoints back in, and we'll run it and see watch what's going on. Enable all breakpoints. Oh, I should have put it one line up. That's okay. It'll stop there. I'm not going to worry about the breakpoints in customer. They all do the same thing. Okay. Define it exactly what I want it to do, and this is where I'm putting the query in. Here's the query from detail in whichever context instance I pass in. Details also include the products where detail order ID equals whatever order ID I've passed in. Okay? So again, this is, if you've never seen this before, it's a little hard to grasp at first. Don't worry about the actual details of how that goes together, because you can spend time looking at that and figuring it out and learning it at another time. I just want you to see the overall concept. So if I haven't done this yet, when I instantiate, then I'll go ahead and compile the query. This will go ahead. I'm compiling it, right? I'm compiling the query into comp query func. So it exists. Now my query is getting called down here, and all I'm doing now is invoking the function, the func, invoking that func, passing in the context instance I want it to use, and passing in that order ID value. Does that part make sense? So I'm just invoking it. And then invoking it will run the query, but it'll run the compiled query. So that the pre-compiling is doing all of that work of the command trees and coming back to the native query. All of that work is done. So it's remembering the pre-compiled query now can go directly to the SQL. It doesn't have to do all the work of translating it. So I'm going to run this again. I'll select some details. I've hit a breakpoint, but notice, and now I instantiated, I should have put the breakpoint above. I did hit the constructor, right? But I didn't hit this compile method because it was already in memory, okay? And so all I'm going to do now is just invoke it. So you get to use it, you can just reuse it, so it doesn't have to go through all of that work all over and over again. And then the nice thing is, for a web application, because this is static, this function is static, as long as that application stays running, then the compiled query stays in memory, and it doesn't, for every different user, 100 people could be using it, but it's not going to have to recompile that query every time, because it's going to be already instantiated in memory. So we are winding down. See what's in here. You'll have access to these slides so you can see how this breaks down. I want to point out, if anybody's in this scenario, and I wrote an article about this for my data points column in MSDN magazine. If you're using SQL Azure and your web app is in the cloud, and you're using Entity Framework and SQL Azure, and your web app is also in the cloud, everything's good. But if your application is on your own servers and you're going up to the cloud, be careful of lazy loading, because if you're doing lots and lots and lots of round trips, you will be lazy loading when you're on the same computer or in the same network, same place, and you're not going back and forth across the wire. It doesn't really look a lot different in terms of performance than some of the other features you might use, other ways of loading. But when you do it against a database, SQL Azure, it doesn't even have to be Azure. It could be just a hosted database. But if the hosted database is in a very different place than the web application, you really need to consider, that's a really important place to do profiling. Really, really important, because you would be surprised at the difference between what the profile gives you, the difference between the performance when it's all local and the performance of the lazy loading when it's spread apart. The other thing I want to just put in your head is about big databases. If you've got a huge database, and I see so many people do this, they'll go create an entity data model from my database with 785 tables, right? So I just want to say, don't do it. So for so many reasons, performance is one of them, but the other thing is just for usability, and you really should be thinking about your domains and making smaller models. So that ends up being, make smaller models, and there's also other tools. You don't have to use what's inside of Visual Studio. Yeah, and there's also other ORMs. I'm sure Stephen will be happy to tell you about them, another one of them. So that's my message. That's all I can show you in the short amount of time. We've got 1 minute left. I think what I'll do is take 1 minute worth of questions. You had a question. Is it still in your mind, or did I answer it? Okay, if this is more than 1 minute, we're screwed. Where? Change tracking? Oh, this wasn't the 1 minute one. At worst case scenario, you can harass me at lunch or tomorrow or whatever if you have questions. The as-no tracking, where is it? Anyway, okay, yeah, there it is.
Yeah, that's the one. So when you add that as-no tracking, and you said that the list might have maybe 100 customers, but you're only making changes to the first and the second, and you're trying to save them. So when you do save them, how many updates would get fired when you turn off tracking?
In this case, only 2. Entity Framework will only update what it needs to update.
How does it manage to do that without tracking?
Without tracking?
Yeah.
It doesn't. It's not tracking. If it's not tracking, remember, the key is in those state entries, right? When it's tracking, it's creating those state entries. And it uses those state entries to do the updates, to do the save. It reads the state entries. If you're not tracking, they're not there, and it won't save anything. It'll say there's nothing to do. Okay, we can talk about this more. Does anybody else have a quick question? You can come up, and if you need to plug in, Steve.
All right.
Okay, honey. Time out.